Hello and welcome to Spectacular Science, the science of sound. Today I have with me a couple of little volunteer sample students, and we're going to start by asking them a question. Tell me some of your favorite sounds. What are some of your favorite things to hear?
You go first? Okay. Mommy's compliments.
Oh, I like that one. That was a good one. What else? Other things you like to hear?
Nana and Papa's voice.
Oh, that's a great one. I love that one. I love birds too. I even like drums. Have you ever wondered how sound works? How it works that I can talk and you can hear me? So to understand the answer to that question, you have to learn something very important about sound. And that is that sound is a vibration. Now that might be a new word. Can you say it with me? Vibration.
Vibration.
Very good. Are there any guesses as to what the word vibration means? What do you think?
I think it means... I don't really know.
You don't know. All right, well, that's what you're here to find out. Do you have any guesses?
Something shaking?
Very good. A vibration is something that shakes back and forth. Now, as you're teaching this, if you get guesses that are totally off, try to look for something in them that's correct. If you can't find anything that's correct, then say, that was a really great hypothesis, that was a great guess, but I'm looking for something different. And if nobody knows what the word vibration means, then you explain it. Vibration means to shake, usually really fast, back and forth. So I want you to show me a vibration in your hands. All right, so your hands are vibrating. Sound is a vibration. Put your hands on your throat, and I want you to make a sound. Ah. Can you feel your hands vibrating? Can you feel your throat vibrating? That's good, because when you speak, your vocal cords vibrate. Remember, sound is a vibration, a shaking, a fast shaking back and forth. So when you speak, your vocal cords vibrate. And then the air in front of your mouth vibrates. And those vibrations pass through the air all the way to somebody else's ear. And then inside your ear you have teeny tiny little bones that, what do you think they do?
Vibrate.
They vibrate. And those vibrations tell your brain what you heard. Now, you can feel it on your throat when you talk, but you can't really see the air vibrating. It's kind of hard to picture what that looks like. So to help us see what vibrations in the air look like, we have a slinky. Now I need 2 volunteers. Let's take you 2. How's that? All right, come around over here. Go ahead. You can be here. All right, you are going to be our vocal cords. So go ahead and hold the slinky. And you go ahead and hold the slinky. Now normally it's better to do this so we have a little more room and the kids can spread out a little further and you can make the slinky a little bit tighter. But given this room, we'll go ahead and do the space we have. So our vocal cords are going to vibrate. The ear is going to hold still to receive the sound. Okay? So now go ahead. Oh, it's not quite a shake like that. That's a different type of way that things move. But vibrations, air, sound waves, vibrate in a different way. It's more like you tap the slinky. Go ahead and tap the slinky. There you go. That's how sound vibrations travel. They start in one spot and then the vibrations, the shaking, shakes the air molecules next to it, shakes the molecules next to that, all the way to somebody's ear. Now to me, this kind of looks like the waves of an ocean. And that's actually why they call them sound waves. The vibrations that transmit your words to somebody else's ears travel like this and are called sound waves. Okay, and you can kind of see how they travel using the slinky. All right, now there's one more thing I want to teach you about sound waves. Come on over here. Now tell me again some of your favorite sounds. I love to hear birds. What else do you love to hear?
Pretty music.
Pretty music. What else?
The waves crashing in the ocean.
Oh, that is a beautiful sound. I love that sound. So is there only one type of sound in the world or lots of types of sounds?
Millions.
Millions, probably even billions of different types of sounds. Well, scientists got to wondering, what makes one sound different from another sound? How does that work? Why are sounds different? Because scientists like to study these things. They like to understand why things are the way they are. To help them figure that out, they decided to study sound. And when they studied it, they decided it would be easier if they could find a neat way, a nice way to draw out what they kind of think sound looks like. So they decided to draw it out like this. These up and down wavy lines are the way scientists picture what sound looks like and what it does. Now you can see in this picture, this wavy line, they're all pushed together, kind of tight. Now this represents a vibration that's really fast. Show me a fast vibration. Very good. When something is vibrating really, really fast, the vibrations are really close together, which you see here in this picture. The vibrations are really close together. It's vibrating really, really fast. And what scientists realize is when that happens, when something's vibrating fast, when those sound waves are close together, it makes a high-pitched sound. Can you make a high-pitched sound with me? Oh, yes, there we go. High-pitched sound, that means your vocal cords are doing really fast vibrations, okay? Because they're pressed together, they're shorter, they're faster, it's vibrating faster. Now, if you have slower vibrations and they're a little more spread out, then you have longer, slower vibrations and a lower pitch sound. Can you do a lower pitch sound with me? Oh, okay. So longer, slower vibrations cause a lower sound. A good way to represent that is with some chimes. We've got some chimes over here. And we have this shorter chime. Now this shorter chime, when I hit it, is going to vibrate faster because it's shorter. By making something shorter, you can make it vibrate faster, so you get a higher pitched. It's a pretty high pitched sound. While over here, we're going to have a longer pipe. And so it's longer, it's going to vibrate more slowly. What kind of pitch are we going to get? A higher or a lower pitch?
A lower pitch.
Let's test it. Compare that to this. You hear the difference?
Mm-hmm.
This one's vibrating faster, and so it's a higher pitch. This one vibrates slower, it's a lower pitch. So as you have a shorter distance, a shorter pipe, you get a higher pitch and faster vibrations, and a longer one you get a lower pitch and slower vibrations. Now for older students, you can also explain that length is not the only way to change the vibrations, how fast something vibrates. A really good example of this is guitar strings. They all have a different pitch, but they're all the same length. It's because there are other things that can affect how fast something vibrates. On the guitar strings, for example, the density, the diameter, or the tension of the string will change how quickly that string vibrates, how fast it vibrates, and therefore change the pitch that you hear. And so there are other things that affect pitch, but what we want to focus on, the one thing we want you to remember is faster, closer together vibrations will make a higher pitch. Longer, slower vibrations will make a lower pitch. Okay, now that concludes the explanation portion. But now we're going to show you the hands-on activities that will really help the kids remember these different principles we've explained.